construction. We're going to have the indoor unit mounted on the wall up on the mezzanine.
Ugh. This to me, man.
I know.
You make me work up in that mezzanine. I just know you are. I know you are.
Eric, you do the inside stuff. I'm going outside and stand up.
Hey, everybody. This is Make Trades Great Again podcast. Andy and Eric. Andy, let's talk about next week.
Yeah.
By the time everybody hears this, I'm going to be in an airplane.
That's right.
On my way to your house.
Yep.
And we are going to do another job together. And this has always been, or not always, I've only done it, a couple times now, but this has been a highlight of as I look, let me start that over. My goodness. What a day. The couple times that we've worked together has been a highlight for me because I have so much fun doing it, and I never get to. I always have to work alone. So then working with like one of my best friends is like, what? This is great. Ah, man, I'm not trying to be all soupy on you there. But anyway, we're going to be together next week in Missoula. And as everybody hears that it's going to be happening, we're going to be working on your shop. So tell everybody what we're going to do.
Well, I pestered Viessmann for a while, and they have given us the hookup on a little AW100. Air to water heat pump. And so this is going to be to like some people, they're going to be like, wait, you just like trash talked on air to water heat pumps and how they don't work. And to clarify, they don't work if you put them in the wrong application, and that's on me. But
I think we were clear about that when we talked about it in the episode. I mean, it's application based.
Yeah. And so that's kind of where this project is, my shop. When I built this shop, what was it, 13 years ago? 12 or 13 years ago. It's been that long. I geeked out with the assistance of John Barba and some of his, you and I had just taken the hydronic soup to nuts class. We were in Rhode Island about that time frame. And I really went down a rabbit hole, which has kind of changed how I think of envision radiant design. Okay. And I went down that rabbit hole, like, how do I make a slab more effective? Right? Like what kind of costs, what kind of things can we do ahead of time
to make it perform better?
Yeah. Okay. To make it perform better or perform the same, but at a lower operating cost.
Yeah, right? I got you. Yeah, I'd say better in that case.
Yeah. And so one of the things that I'd looked at, and everybody uses we want to maintain a 80-degree slab temp, or 78-degree slab temp, whatever these rules of thumb are that are out there in this design software. And so I kind of threw design software out the window and went back to the calculations, and
the maths
of it, and said, well, how low of a temperature can I go? And what impact does under slab insulation have? What impact does perimeter insulation have? And, went through John's, got this freaking cool, I'm going to call it John's. I assume it's Taco's property, but John introduced me, so inherently it's John's. But his heat loss calculator, he's got a manual heat loss calculator. It's not manual J, but it's along the same lines.
The room by room form, like the literally manual form you fill out by hand. That he's got. It's based off of manual J.
Yeah. And so I went through and I did all the calculations of that, and I was like, okay, here's my walls, here's my windows, here's my doors, where's my heat loss, without insulation, right? Without under slab insulation. Okay, perfect. Then went in and said, let's do it with, under slab insulation. How can we eliminate a 5,000 BTU load, or how can we eliminate this, right? Because I looked at it at that time and was like, well, if my downward heat loss is like 6,000 or 8,000 BTUs, right? Which I don't think it's that high. Maybe it is 1,200 square feet. Dirt.
I bet you it's at least that.
It probably is that.
That's probably right.
If I can eliminate that, and it costs me $1,000 in 2-inch blue board at the time. Certainly,
I don't even know
more than that now, but I get to save that 6,000 BTUs an hour forever.
Yeah.
Right.
Yeah.
Like that.
More or less. Yeah.
More or less. And so when we built the shop, I was like, okay, I'm going to insulate the outside of the concrete foundation. And I did 2 inches of insulation on the outside. And I did 1 inch of insulation. And I did 1 inch on the outside of the. No, 2 on the outside, 1 on the inside perimeter. On the, I got a 3-foot foundation wall under my shop.
Yep.
So it goes down into.
Well, it's a stick frame building, so you have footings and.
Yeah, I have a footing with a
foundation.
Yep. Well, it's not block; it's a poured concrete.
Oh, we use block here for that all day long. But yeah.
Yeah. So poured concrete, 2 inches of polystyrene on the outside, 1 inch on the inside, and then 2 inches underneath the entire slab.
Yep.
Long story short.
I mean, that's normal setup.
Normal setup now.
1 inch extra, it might be. I mean, 1 inch.
Yeah.
The additional 1 inch on the inside might be a little different than normal, but
right.
Than what we typically see.
And so what I ended up with is a slab that so I got to that point, and then I said, well, I need to deliver
calculation.
Right. I need to deliver like 20,000 BTUs total to heat this thing on a design
That's your
day.
entire heat load?
Heat load. Yeah.
Wow. It's really low.
Nothing. Yeah. It's nothing.
That's super low.
And so I looked at that and I said, well, how can I do that with lower water temperature? Right. It's all about differential temperature. What's the lowest slab surface temperature I could achieve 58 degrees at? Right. Because that's my set point, 58, 60 degrees. That's what I want the shop to be. I'm going to be out here in a, flannel or a sweatshirt or, whatever. It doesn't need to be 70. And so went back, redid that calculation as well, because we always factor in that it's going to be 70 degrees in the building or 68. And so drop that 10 degrees and, I can heat my shop when it's 20 below zero with 74 degree water. And I achieve that by basically taking the tube spacing and going from the traditional, like everybody's like, oh, you need to go, 12 inches at the perimeter and then 18 inches in the middle. And instead,
what?
You've never seen that? Where people do a perimeter band and then they get narrower spacing towards the middle of the room.
So but based off the Uponor design manual, the Wurzbo,
right?
Radiant design manual, I should say, because Uponor rebranded it. 9 and 12 is what I was taught. But go ahead.
And so
18 inches in the middle, like that seems crazy to me, but it probably works. But I wouldn't.
Yeah.
Personally,
because I didn't. And so I was like, well, I mean, I don't really care. I'm gonna not normally be walking around barefoot in the shop. Not recommended with metal shavings and dirt. And,
well, it's a garage.
It's a garage.
It's not a living space. It's never going to be a living space.
Right.
Well, I guess it technically could be, but
so we went in and did 9-inch tube spacing. It's stapled directly to the foam, and then there's 5 inches of concrete on top of it.
Yep.
And that a lot of people would be like, oh, you need your tubing in the middle, for faster heat up. I don't. I want that tube right there where the whole slab is up to temp. It's continuous. It's single zone. I'm not doing day and night setback or occupied setbacks or anything like that. It's just maintain 58 degrees.
Yep.
And we can achieve that by having really long run cycles. And so I've got a 6 kilowatt electric boiler on the wall now. At the time, I don't know exactly why I didn't, but I could have plowed a gas line from my meter that's up at the house back to the shop.
I remember the conversation about that. It was just
50
cost.
feet.
It was just literally like, you're just like, well, it would be a huge freaking job. Why would I do that? I can just do it with electric.
And there was
also, I remember the conversations being that you couldn't get a small enough gas boiler.
Right. That was my ish.
Yeah.
Yeah.
Yep. For 20,000 degree or 20,000 BTU an hour heat load at design, by the way, because you're probably really running 10,000 BTUs at any given normal time, at least during the day.
Well, and that's where I'm kind of excited about this heat pump, because it's got a 20-gallon buffer tank that it's set up with, and then it's a inverter heat pump, so it's just going to maintain that buffer tank on outdoor reset.
Yeah.
And I'm also excited because I'm going to do what everybody says not to do, and that is I want to play around with some radiant slab cooling, just for my own, on my own enjoyment, entertainment.
What do you think? Everybody, what do you mean? Maybe that's just maybe you didn't mean it the way I think you mean, but what do you mean? Everybody says not to do. I mean, in your climate, it's gonna be fine.
It's gonna be.
You're
fine.
Saying not to do it because you don't have any dehumidification,
right? You don't have control
equipment
over
or anything like that.
Yeah.
I got
you. And it's a heavy slab, so it's hard to maintain that. But here's the reality of it. My opinion is, if I could get this slab to 55 degrees, I bet that, and it's not going to be far from that anyway. It's not going to take much energy to keep it at 55. 55 is well above any reasonable dew point that we're going to experience because of our low humidity in the summer. That if it's not ever going to be a condensation issue. If I had it down to 45, then sure. I mean, it'd probably condense and sweat and cause all kinds of, issues that I don't know about yet. But that's my objective is like, can I get this thing to, can I maintain a 55 degree leaving water temperature?
Yeah.
Is that feasible? Is it possible? And what does that do to air temperature?
Yeah.
And that's what I want to play with, because I have I have a number of customers, large, big customers that have I've got one of them in mind that would love to cool his shop. That's like a 45,000 square foot shop. And he's like, how can we do this? It's a big, like 15, 16 bay diesel truck shop.
Yeah.
And he's like, the guys just sweat. It is so hot in the shop. And he goes, we run those great big fan box, evaporative coolers. He goes, they don't work very well.
Unless you're standing in front of them.
Yeah. And he goes, it would be sweet to just take 10 degrees out of the room. Can we do it safely? And I was like, I don't know, but maybe. So I've got, like, say there's 2 or 3 of those big shops around town, and it would be like, if we did a heat pump chiller,
that'd be pretty sweet. So for clarity, anybody that's not familiar with, you talked about the dew point, and you talked about the slab, and you talked about cooling, and you covered that pretty well just now, but I just want to go back on that for a second.
Yeah.
You have the potential to make like a skating rink, let's call it. You're not going to freeze the water, but your slab is going to sweat if your dew point is too high, because the closer you get to the dew point with the temperature of the slab, okay, the faster the higher likelihood you're going to start seeing condensation on it.
Yes.
And we don't want condensation on our slab. It's not going to hurt anything.
No.
But we don't want to condense the moisture in the air in the environment just because we're trying to cool it down. And the whole point of your cooling system is that airflow pull the moisture out. And you can't do that with this because you're moving the air and pulling it out and evaporating it, which is what a traditional AC, coil refrigeration system does.
Yeah, that's part of where the radiant cooling doesn't get super effective, is that it doesn't do moisture control.
You have to have an additional system like that. But radiant cooling is effective. It's efficient.
Absolutely. Yeah.
Because it's
going to absorb heat.
Yeah.
Yep. And that's kind of where I want to play with it a little bit, because I mean, ultimately in that case, I mean, we could set these customers up with some sort of dehumidification, drop the dew point in a shop like that. I mean, granted,
it's hard.
45,000 square feet is a lot of space.
The doors,
especially when you have a wash bay. Things like that.
Up and down overhead doors is really the biggest.
Yeah.
Radiant cooling, I think, would be ideal in like a living, like a barn dominium, let's call it, right? So like your living space, slab on grade, radiant cooling would be great in a scenario like that, because you're not, exchanging the air and the volume of air in the space by opening up the door,
right,
20 times a day or even once a day. You know what I mean?
Yep.
It's interesting to the cooling part of it is intriguing to me. And here's why I wanted to talk about the dew point and hit that hard for you guys. So, anybody that's not familiar, Missoula, Montana would you say it's an arid climate? Is that technically true or?
Yeah, it is. I mean, our humidity swings are like insane. I mean,
what do you mean?
Today they're insane because like right now it's 70% humidity, but it's only 45 degrees out. And, tomorrow, let's see, at 5:00, I'm going to go from 80% humidity at 3 a.m. to 30% humidity at 6 p.m.
Do you want to know what it is for me right now? So I'm bringing it all up because I brought up, I'm trying to find a good, reliable, like, give me a good set of data here on, like a free weather.
Yeah.
So I went to Wonderground. You've used that, right?
Yeah. Yeah.
They're good. It's just a lot of ads on it, but I'm going to share my screen real quick. Can I do that while we're talking? Every time I try to do this, I don't think I know how to do it. Allow. Okay. You ready? Can you see my screen? Yep. Okay. So sorry to everybody that's just listening and not watching on YouTube. So right now it's 69 degrees, 69. Feels like 69. It's going to be 82 today, partly cloudy right now. Okay, you ready? Today it's supposed to rain, but the rain has nothing to do with what I'm about to tell you. Look at right here where my cursor is. I don't know how well you can see that. It says conditions. It says barometric pressure 29 inches, visibility 9 miles, clouds partly cloudy, dew point 67. Humidity 93%. Okay. So we have 93% humidity. And you would say that your swings are wild because it's very high right now for you. 70 something percent is high for Missoula.
Yeah.
But it's also morning time, like you acknowledge, it'll dry up as the day goes on. It doesn't, is that an elevation? It must be a product of elevation, right?
Yeah.
It doesn't do that here. It dries when the weather patterns change. Sorry, I just hit the microphone there. So at 67, the closer we get a slab to 60, in my case, the dew point is 67 degrees Fahrenheit. The closer we get our slab to 67, the faster we start seeing water condense on the surface, right?
Yep.
Okay. So 93% humidity and 67, like a 70-degree dew point in Minnesota in the summertime, June, July, August, is not crazy. It's wildly uncomfortable, but it's not, it's like normal. It's tropical. And people don't think of that as, where I'm at. And I would have expected your humidity to be higher, like, hey, you guys are like closer to the Pacific Northwest in a sense.
Right.
Like to me in my head, like that makes sense. But it's not the case. And it's humid as hell here. And so radiant cooling, like in my shop, would not be
tough. Yeah.
It would be, I honestly it's not. Like you said, people say don't do it. Yeah, they're talking about like conditions like I work in all the time.
Yes. And that's like, I mean, tomorrow, like I said, we're going to be up to 80% humidity. That's at 3 a.m. and our dew point's still 39 degrees, right? Because it's cold out. So
that's it. Okay. So now your dew point's 39 degrees. So your humidity can be high. It doesn't matter. Your dew point's so freaking low.
Right. So I just out of curiosity, just while you were talking about there, while you were showing your graphic, I said, well, what's the lowest recorded humidity in Montana? Right. Like what do we get to? And in 2021, so just a few years ago in Billings, it was recorded at 4.7%.
Jesus.
It was 102 degrees and 17 degrees was the dew point.
You go outside and you're like, I need to moisturize. Yeah.
You just dry.
Your hair starts on fire.
Yeah. Yeah. You guys get that, the inverse of that when your trees freeze, right?
Yeah.
Crack,
yeah.
Right. We get the same, same concept when they're drying out.
Exploding trees. Yep.
Right. You'll go out and when it's in that under 10%, and that happens pretty much every year where we'll get single digit humidity. If you're out in like heavy timber, you can hear things cracking and that's the trees drying up. Yeah, it's
falling
just
apart.
freaking wild.
The exploding trees in Minnesota
that's a whole different
is a extreme winter phenomenon, and it's the water in the trees just like
poof blowing up.
Can you imagine just exploding? Like it's a living thing. It's a tree. It's alive.
Yeah.
Like
it
doesn't have a heartbeat, right? I don't know. I don't want to get into that. But anyway,
they have feelings.
No,
too,
so we're gonna remove the electric boiler on your shop.
Yep.
Okay.
Yep. I'm gonna repurpose.
That's gonna go away. You're just not even gonna use it on your shop. It's gonna go to another job.
Yep. It's gonna go across the street to my neighbor, built a shop, and I'm gonna donate my old boiler, which it's an electric boiler. I mean, nothing goes wrong with them. The control might go bad. Get a new control.
It's not old in the sense. Yeah, it's not old in the sense that it's mechanically old.
Yeah.
You know what I mean? Like there's nothing really, like you said.
And so
solid state relays, big deal, $40 a pop.
Yeah, there's nothing to it. And so that's the beauty of that. And it was, part of the factor, we talked about this a minute ago about, cost of installing a gas boiler, right? I couldn't get one that was small enough. B, I'd had to run a gas line out to the shop, 150 feet. Venting. And then I got to maintain the dang thing because I'm not going to put in, your standard efficiency boiler. Well, you know what I've done to this electric boiler in 13 years?
Nothing.
I have a Swifter duster. I've dusted it. Right?
I've dusted it, he says.
I
went over there and it's kind of dirty. What's that? Oh, it's just a cobweb.
Right. Right. I mean, so there's a huge piece of me that goes, you know what? Electric boilers are great from a cost of operation. Now, if you have high electricity, they're not great. Right?
No, I mean, they're great in certain scenarios.
Yeah.
Like not logistically. Let's just how they operate and everything. They're fantastic, especially for low heat loads.
And our electricity is not super high. I mean, we're like 11 cents a kilowatt, so it's not terrible. We don't
That would be on the low end for the country.
Yeah. Yeah. We're not lowest for sure, and we're not far from highest.
Oh, God, you're 3 times lower than the East Coast. I think they're 30, 40 cents on peak hours.
Yeah. Yeah. It's crazy. And I don't, and that's one of the things that I'm looking to to avoid as well. You glitching out over there. Yeah, I did. What was it?
Is it storming? I don't know. It's weird. My lights just flickered.
Yeah. But anyway, it's one of those things that I'm working with the utility right now, talking about what kind of rebates can we do? How can we do this? We don't do demand metering here. Like peak load metering like you guys do.
Yep.
However, we do have demand and peak load rates, but the meters don't have the ability to disable, switch over into alternate fuel sources. And I'm less concerned about that. However, if I may look at some things and figure out how to make my system go to sleep during peak load hours, right? I mean, ultimately, my goal on it is
you could just do that with a thermostat.
Yeah. How can I get my shop to be less expensive to heat? And I mean, by expensive right now, it's like
your goal is just literally how can I just lower the cost? It's not because it's too high. It's just you're just trying things.
Yeah. Let's just experiment with it.
Okay.
Would I have loved to put in a CU3A? Absolutely, it would have been cool.
I know. I think about that.
But then again, I'm like, the smallest CU3A I can get is 90,000 BTUs.
I know.
It's 5 times what I need. Could I put in a massive
the only boiler I know
with
with a built-in buffer, though.
Yeah.
You know what I mean?
And it would have operated fine at 20,000. Right?
I wonder if you could use a CU3A as a buffer tank. Interesting.
Yeah. And
if you hooked a heat pump to it. I bet you they're thinking about that.
That'd be cool.
Yeah, the idea of heating the shop, like my own shop, I've thought about it with a heat pump because they too have went, hey, you want to put this on your shop? I'm like, well, I mean, no, only because I already have a gas boiler. You know what I mean?
And gas is cheap.
It is.
Crazy cheap.
It is cheap. It would, I would increase my operating cost average, just, by the end of the, full season operating costs, it would be higher if I went to electric than if I stayed on gas.
Yeah.
So here's how I design every garage. And honestly, most radiant systems is the same way you did it. But we don't do, like, I would never go more than 12 inches on spacing, 1-to-1 on the ratio.
Yep.
9 inches is just the go-to for me. And it's all based off of exactly what you were thinking about 15 years ago. And I'm the same way. And it's no surprise because you and I talk about this like all the time, together, just privately, like that's our entertainment sometimes. But the 9-inch spacing, your 1.3 is that ratio. So like if you just want to look at your square footage and you go, okay, well, if I have 1,000 square feet and I'm going 12 inches spacing, how much tubing do I need? Well, you just divide it by, you just divide it by 1. Or times it by 1, or however you want to look at that. But then if you go to 9 inches, you take your 1,000 square feet times 1.3 because you're putting 1/3 more.
Yeah.
That's the difference between 9 and 12 is, 1/3. And so, or 30% more. And so you're putting 33% more tubing in. The math is so simple. 1.3 times your square footage. And that's going to be your quick math, right?
Sure.
But what that does to you is now you've got capacity. It's not 1-to-1 on the output, but you're basically can look at it like this, because the engineers will correct me on this, but for the purpose of this conversation, it's close enough. You're going to have 33% more input into the slab per square foot.
Right.
Now, you talk about being able to lower water temperatures because the energy level needed remains the same, but the energy level that we can give it is above what's needed. So now we can start dropping input temperatures, which is a direct correlation to lower energy input cost or consumption. It would be the same with electric as it would be with gas, or if you're burning freaking wood. You just can't quantify it with the wood as the same way as you can and meter it with a typical utility. I think it's fantastic. And I did that quick little video. I think you remember it this winter. It was like 24 below or something like that. It was crazy. I think it was like 20 or 22 below zero. It was like 6 o'clock at night. I just pulled the van in. I was working. And I walked over there and be like, this is the opportunity to show it, because people just won't believe it. And it goes back to what you open up the conversation with about design. Everybody wants to, everybody learns one way or another, but oftentimes it's kind of consistent across the board. In my area, it seems like everybody wants to set up a heating system with like 120 degree water.
Right.
I don't know why they do that. It's absolutely nuts to me because I guess I just trust science. And I took the time to understand it like you did, as much as I have the brain capacity to do so. And it came down to, I think people just don't trust outdoor reset because they don't understand it. And so they just set point temperatures on these slabs, which is absolutely insane. Because at 20, let's call it 20 below that night that I took that video, my water temperature literally was like 77 degrees.
Right.
Something like that. It was under 80 degrees. Yeah. Think about that. I'm below design temperature because my design temperature here in the Elk River, Zimmerman, East Central Minnesota, my design temperature according to ASHRAE is 14 to below zero. Yep. That means I got to maintain set point temperature, whatever I designed to, like let's call it 70 degrees. 72 is what the ASHRAE standard is for your home. But let's say I want to heat my shop to 72 degrees and I got to maintain 72 inside at 14 below. Well, at 20 below, I'm doing it with under 80 degree water, or maybe it was under 85 degree water, whatever it was. It was
regardless,
crazy low. And I'm only able to do that in those conditions because of how the tubing was installed and everything. Like, slab was insulated, everything.
Yeah. Well, and that's kind of where I was. So the other night I was, must have been Sunday night. What night did we talk? Was it Sunday night? Monday night?
Yeah. Yeah.
Anyway, we were chit chatting about stuff, and I grabbed the manuals out of the box, RTFM, because it's been a hot minute since I've installed one of these Viessmanns, and
it's been over a year because you and I did one.
Came out to
November.
We did it to Doug's place, and anyway, so I was glancing through the manual and the tech design manual and whatnot, and checking pipe sizes, pipe connections. And then, I was sitting there going, I'm going to have to upsize my piping. to do this between it. And then I was like, wait, no, I don't, because I have the little bitty guy that has all of the exact same components as the big one, like same pump, same monoblock heat exchanger outside, same heat exchanger indoor, except it's got a smaller electric backup. Yours, I don't think had no, we disabled the electric backup on Doug's, I think.
Mm-hmm. But it did have it. Yeah.
It did have it. So with the little one, my max flow rate's only 4 gallons a minute.
Oh, really?
And so it's not that 12.8 or whatever with the 25 feet ahead. It's 4 gallons a minute with 1 foot ahead. So it's nothing.
Right. Your head is so low, head loss or your head pressure is so low because your gallons per minute is so low.
Yeah. Yeah. So anyway, I'm looking at that, and then I was like, oh, look at this. The COP on this unit at 75 degrees discharge water temperature at -5 is like almost, I think it was like 1.8. I was like, this is going to be sweet.
It's going to be better than your electric for sure.
Yeah, because the electric
going to lower your operating costs most likely.
I don't know how I can.
Yeah.
So I mean, -5 is a really common. We don't really. I mean, occasionally we get to that. I mean, design.
What's your design? What is your design?
-13.
Yeah, same as mine.
Yeah,
same as mine.
So I mean, it's less than 2% of the time.
Right.
So, which it'll be cool to be able to watch that thing just kind of chug along at low temp.
Yeah, it's exciting to me. I don't know how exciting it is to everybody listening, but the whole idea is just kind of flip the script a little bit. There's energy. These heat pumps are just pulling the energy out of the atmosphere.
Yep.
And obviously that's a moving target because your temperature changes, your humidity is going to affect that a little bit. I guess technically, and the engineers will say for sure it does. All those varying conditions, but you have a massive amount of energy is available out there.
Right.
And we're just going to move it from one place to the other because of the heat pump technology. What's the pipe sizing between the unit and the buffer tank? Because like at Doug's, we had to go, about 40, 50 feet.
Yeah.
And based off the gallons, we had to maintain specific gallons per minute through it.
I think. Yeah.
Right. But we were also using the built-in pump without adding a separate pump. And so I had to upsize my piping between the two units, an 1.25 inch Uponor. Has nothing to do with branding or anything like that. It was just the expansion packs when you did the sizing. The expansion in those scenarios, expansion packs does make a big difference. I'd say for flow rates. It doesn't really matter to me, like for water distribution, a typical home application, but like in this case, we're able to go with 1.25 inch cold expansion packs between the two units, oxygen barrier, of course. So what are you able to do it just 1 inch then?
Yep. We're going to go 1 inch.
I mean, you probably do it with less, but of course you're not going to.
Right. And I was looking at that. I was like, well, could I do 3/4? And I could easily get 3/4, but then I'm reducing from 1 inch on both ends and putting a piece of 3/4 in there. And I was like, it's 15 feet from
I was going to say, you're not going
indoor.
100 feet. So like you're not saving anything.
No. So I ended up picking up, and I've been a big proponent. I really like the Rayhow PEX right now. Yeah. So we're going to do Rayhow PEX. I've got Viga PEX press fittings. Okay. And the reason why I'm doing that is they're smaller, so it's easier to insulate. So I jumped on Supply House.
You're not losing capacity by using the insert fitting for your application.
No.
And that's the only reason we went to expansion packs on the system you and I did was to increase the flow rate.
And that's something you got to really watch with, even with expansion packs with F1960 fittings, is like specific fittings like male adapters are heavily restricted.
Yep, you're right.
And especially by brand specific, they have a lot of friction loss in that male adapter. And you gotta look at that and go, okay, well, what's going on here? So in my case, again, we're upsize at least one pipe size. And so I picked up, what the heck do they call it? it's like the UV DuraGuard insulation. So it's a UV rated, jacketed foam insulation.
Yeah. Is
same
it the
stuff
black
they
stuff?
use. Yeah, it's the black. Got a really heavy rubbery jacket on it.
Yeah. Is
Supply
it
House,
split or is it?
This be a slide over,
Yeah.
which I actually appreciate. I wish I could find that stuff in split easily. It's available. You can buy it.
It's nice to have a couple sticks of it, so when you're doing your short pieces and stuff like that, after the fact. But your long pieces, the slide over is fine.
Yep. So we'll basically come out of the unit, make a little horizontal offset is my plan. I'm going to do it without 90s. We're going to use bend supports. A metal bend support. So I should be able to insulate directly over a metal bend support. So we'll have nice radiuses going in, and then we'll be in line height up the outside of the building. We'll go up like 9 feet, and then we'll come in basically above the podcast studio here. And across that little mezzanine. And I rethought this from our conversation. We're going to have the indoor unit mounted on the wall up on the mezzanine.
Ugh. This to me, man.
I know.
You make me work up in that mezzanine. I just know you are. I know you are.
Eric, you do the inside stuff. I'm going outside and stand up. And then we'll put the buffer tank right up there and then pipe down inside the wall down to the radiant manifold that's in the bathroom.
Okay.
And I think it should work out pretty good. The mezzanine's, it's a 4 foot tall space above there, so it's not like it's super short, but
is it plywood or what is it?
It's OSB deck up there, so it's a storage deck now. I'm going to put a sheet of plywood on the wall, so everything will be mounted up on a piece of plywood on the wall, and I think it should be pretty straightforward. The flow of piping should go across nicely. I don't have an indirect yet that I'm going to do in here. I mean, my only hot water load right now is just the hand sink in the bathroom. So
I have the combi boiler, so gas back to that, I have the Weissman combi, which how I feel about combis, but for the shop, it makes total sense. Yeah. I bet you I use in a year's time, 20, 30 gallons of hot water.
Right.
You know what I mean?
You don't wash with it.
No.
Yeah. And that was the only thing I was like, it'd be really nice in the wintertime to wash with warm water. And I'm just kind of like, I don't know. I mean, what do it do? I'd have to
How much of a difference does it really make? Yeah.
Right.
I mean, it's nice, I'm sure.
Yeah. So now I'm on the hunt. And I kick myself because I just got rid of a really cool Baderis 50-gallon horizontal indirect.
Oh, is it in good shape?
It was 15 years old, but it's stainless steel tank.
Pretty big though.
Yeah, they are pretty big, but it was stainless on a house with a water softener. And I was like, I could descale this thing. I know that I could.
It's probably not even scaled up.
No. And I chucked it, and I should have just kept it because it would have just slipped right in there beside everything.
And
then
you
I
could have used the
toggle switched it on.
Hot water. Yeah.
Yeah. Be like, wash the van. Let's turn the heat pump or turn the hot water on.
Start it up a couple hours before and just be like, there we go. We're done.
There you go. Yep.
Well, it's going to be fun. We're going to have a video of it and stuff. So you watch mechanicalhub.com for that, our YouTube channels, whatnot. I'm sure we'll put stuff out on social while we're there, of course. I'm looking forward to it. I love this kind of stuff. And it's cool because it's not just a normal system. You know what I mean? Like putting the heat pump in, it's really straightforward, but it's more fun because it's not something you and I have done like 1,000 times. You know what I mean? Like it's a little more entertaining. So I'm looking forward to it. You got all your fittings and everything. Cause like,
I think a lot of that stuff should be arriving here this week.
Okay.
Yeah, we've talked about that before. I have hardly any PEX press available here in Missoula. But ultimately, if I'm using bend supports, the only thing I need is male adapters.
You know that RWC, it's Shark Bite. They have PEX press now fittings.
I did see that. I also saw when I was ordering them because I got them off Supply House because I was like, they could see if I can get them here. Bluefin's got them now too.
Okay.
Which I thought was interesting, but
we
went with Vega. So
I don't know. I don't blame you.
They'll probably give me, Chemin will probably give me flack for not using Vega pipe, but if I could have found a stick of Vega oxygen barrier pipe in Missoula, I would have used it. But
I like that Ray House stuff too. It's got that UV barrier on the outside, so like if you have some of it exposed, it's really not that big a deal. You know,
I'll be honest. The white I stock white in half, 3/4, 1 inch here in the shop, bag of each, all the time.
Yeah,
I like the fact that if it's wet and you put a normal Uponor or a Rayhouse ring on it, it almost never slips. Whereas the Uponor is slick and it'll slip that ring down the tube, and then you're.
I used a lot of it during COVID when I couldn't get.
Yeah.
All of a sudden, Gooden just had a bunch of Rayhouse, and they had always stocked Rayhouse. Gooden Company here in Minneapolis, and I just always had bought Viga or Uponor from a different supplier, depending on what I was running at the time. And then during COVID, it was hard to get anything. You remember?
I do, and I think part of and so what it did, that you're right, it did happen to be during COVID, but it was the first major freeze in Texas that screwed that up. That was that polymer plant that got jacked up with the freeze, and U.S. productions of polymer fittings and tubing was like,
yeah.
And so
I started using it then. I liked it. I'm stocked up on Viga now. Yeah. You know what I had for the longest time was a ton of their black tubing. I'm looking at
it's nice
right now. I still have some of their Viga black tubing, but they discontinued black like a few years ago. That's how much stock I don't go through as a one. You know what I mean? Like I just don't do a lot of install work. So
the black tubing was nice with the Radiant when you put it on those yellow, their Viga grid.
Oh yeah,
rapid grid. With the yellow and the black tubing looked so good.
yeah. Now it's just you got your choice: red, white, or blue, and I just buy white.
That's what I do.
Seems to make sense to me. Like I don't know. All right.
Yep.
We went longer than normal.
That's right.
We're good.
We're good.
Everybody hit us up over. We got some messages too. We acknowledge we got some messages from you guys. We appreciate that. Over on our using the text option. You can even, we learned recently that you can leave us voice message in that. Yeah. Like you can talk to us.
Oh man.
That's really cool.
We can't talk back, but
no, but then it transcribes it for us so we can read it and listen to you talking to us. So now we know what you sound like.
That's right.
And it's just exciting for us, and we do really appreciate it that you give us any kind of feedback. We've been getting some messages over on Instagram recently, just the last couple of days actually, and so that's really cool. I don't think I shared those with you yet, and I will. It's really awesome. The feedback's great. I know some people have been we kind of come out of the woodwork and said, hey, I love it when you guys talk about this technical stuff like the boilers and whatnot. So we're responding to that.
We'll work on it.
Yeah, we're working on it. We don't want to talk about it all the time because I think there's some people that listen to our podcast that are entertained by my stupidity or, especially awed by Andy's good looks. And, there's a variety of topics we are always going to cover. But we acknowledge that you guys have given us some feedback recently that says, hey, we like that. And so we'll mix a little bit more of this kind of talk in like we did today. So, all right, dude. You good?
All right, I'm good. Have a good one.
Bye.
Bye.